Hello, this is the Math 159 Gould Chapter 3, Section 5 video, which is about box plots to display summaries. Okay, so we've learned about different ways to graph numerical data, like the histogram and the dot plot. There's a new one we're going to learn about, which is now called the box plot. So we have previously used the histogram and dot plot. So now we're going to use the box plot. Okay, so what is a box plot? Oh, wait. Let me pause this. So what is the box plot? Let me go so I can draw here. The box plot splits your data into quarters. So you might remember how we talked about the quartiles before. That's the sort of quartile or quarter that I'm talking about. So a quartile is groups of 25%. Okay. And it's useful for, it's also very useful for, so what does it do? It splits your data into quarters. We'll talk about why that's interesting in a little while. And it also helps you determine if it has outliers. Helps determine if there are outliers. Okay, so what do I mean by it splits it into quarters? So let's say that there's some smallest number in your data. We'll call that the minimum. And then we have Q1, and then the median, Q3, and then there's some largest number which we'll call the max. You might recall that the median has 50% of the numbers that are less than it, and then the median is there are 50% of the numbers that are greater than the median. And then what does Q3 do? It splits that 50 into quarters, right? The 25 and the 25. And then Q1 does the same thing. It splits it into 25 and split 25 because it's the median of the lower half and the median of the upper half. Okay, so that's what I mean by it splits it into quarters. So the box plot is basically a graph of your median, Q1, Q3, some smallest number, and some largest number, right? Because it splits it into 4 pieces. Okay, so what we're going to have is we're going to have a vertical line where the median is, another vertical line where Q3 is, another vertical line where Q1 is, and then we're going to use those to create our box. This is why it's called the box plot. Sorry, it's drawn a little ugly, but best I can do. Okay. Then there's going to be another piece called the whiskers that go out from Q3 to a point over here and go out from Q1 to a point over here. Okay. Now, so this is Q3. This is Q1. This number right here is going to be Q3 plus 1.5 times the IQR. So sometimes this might be the max and sometimes it might not be. This number right here is going to be Q1 minus 1.5 times the IQR. It could be the minimum or it might not be. Okay. If this is not the minimum, then there's going to be dots over here, and these are possible outliers. Okay, so there are only going to be dots out past these whiskers if those numbers are further away than 1.5 times the IQR. So I'm not going to tell you where that number came from, but basically the person who invented this years ago noticed that, hey, if you're 1.5 times past the IQR away from Q3, usually those end up being outliers. Okay, so let me doing this by hand is sort of a pain. There are examples in the book, but let me show you how you can use StatCrunch to have it do this for you, and we will do an analysis of it, sort of see how it works. So I'm going to switch over to some data. Here we go. Okay, so what this data is, actually let's zoom in a little. Let's transform to fit screen. Okay, cool, it fits the screen. Okay, so this data is on particular dates in from January 1st, 2006 to basically a whole year of weather data in the year 2006 for two cities, the maximum temperature, San Francisco, California, and Provo, Utah. Okay, so we're going to look at each of the two cities separately. We'll start by graphing. We'll choose Boxplot. It's under histogram, stem, and leaf Boxplot. We'll choose Air Max San Francisco. So if you just click compute, it will show you the Boxplot. And notice it looks sort of like the graph. You can see here is the box, right? With the line in the middle, which is the median. The top one's Q3, the bottom one is Q1. And then there's the whiskers that are coming out. I prefer not to see it vertically. So if you want to see it horizontally, you can go to other options right here and click draw boxes horizontally. And then it looks more like this. Okay, so here's the box that we're used to. You can see here's the box. So the middle line is the median. And if you hover over it, the median is 64. So if you look at all of the max temperatures in the year 2006 in San Francisco, the typical temperature is 64 degrees, right? That's the median. And then Q3 is 70 degrees. Q1 is 59 degrees. And we're told that the IQR is 11. And you can see here are possible outliers at 87 degrees, 88 degrees, 91 degrees, and finally 97 degrees. Okay, so those temperatures are more than 1.5 times the IQR out past Q3, right? So those are unusually warm days is the whole idea. There were no unusually cold days, apparently. Okay, so it draws it for you, but let's sort of talk about the numbers here. Okay, the median is 64 degrees and Q3 is 70 degrees. That's from right here to right here, the right half of the box. That means 25% of the days had temperatures between 64 and 70 degrees. That's pretty comfortable. You have the left half of the box between Q1 and the median. Q1 is 59 degrees and the median is 64 degrees. 25% of the days are between 59 and 64 degrees, and that's the max temperature. So the box plot, it breaks it up into quarters, so you can roughly expect that 50% of your days are going to be between 59 to 70 degrees, which is actually pretty comfortable. And then you get another 25% from Q3 to the end of the whisker right here. The end of the whisker we call the upper limit. So Q3 is 70, the upper limit is 85. About 25% of the days are between 70 and 85 degrees. Anything out past 85 degrees, that would be all of this stuff, is considered an outlier. Now, the lower end of the whisker, the lower limit, is 49 degrees. So 25% of your days are between 49 degrees and 59 degrees. To be a possible outlier, a day would have to be below 49 degrees, and apparently in our data that never really happens. We only get unusually warm days as outliers. There were no unusually cold days as outliers. Okay. Okay, so now that you've seen how the histogram works, it splits it into quarters from your lower limit to Q1, from Q1 to the median, from the median to Q3, and then from Q3 to the upper limit. So let's make this same graph. We'll make a box plot for Provo. We'll have it draw it horizontally. Compute. And you can see that the Provo graph is a bit different than the San Francisco graph. Here, so let's go like this so we can compare them side by side. Or sorry, one on top of the other. So go like this. I like to line them up so you can sort of compare them. Okay. Notice, first of all, I guess the numbers don't line up. You can see 60 is right here for Provo, whereas 60 is up here for San Francisco. So what we're going to do is we're going to make it so the 60s line up approximately. There, that's pretty close. So now you can get an idea of, well, you can start comparing the two different cities. So what's the typical temperature in San Francisco is median 64 degrees. A typical temperature in Provo is median 66 degrees. So the typical day is about the same. But you can see that San Francisco goes, oh no, actually they don't line up because this goes to 100. We need to stretch this out. We need the 60 and the 80 to agree. Okay, I see. This is not going to work very well for us, right? We need this 60 up here to line up with this 60 down here. And we need this 80 to match up with this 80. So I'm trying to make that happen. Okay, so if this is 60, we're going to need to like stretch this a little bit. And I apologize, there are children yelling next door. Okay, so if that's 60, we're going to stretch this one out until the 80s agree. Almost. Oh no, they're not letting us do it. Come on. Let my 60 and my 80 match up, please. Ah, there. Okay, cool. Now we almost have them matched up, right? The 80 matches with this 80. The 60 matches roughly with that 60. There we go. Now they're pretty close. Okay, if we stretch this one out just a little more. Ah, perfect. So now you're going to get an idea of, okay, even though the typical days are about the same, a median of 66 and a median of 64, you can see that Provo has a lot more variability or spread to the temperatures. Because what's the lower limit for Provo? It goes all the way down to 24. But what's the lower limit for San Francisco? It only goes to 49. For Provo, what's the upper limit? 104. But for San Francisco, the upper limit is 85. So you can see for San Francisco, the IQR is 11. But for Provo, the IQR is 37. Provo's measure of spread, or IQR, is much larger. That means that there's a much larger spread or variability to the temperatures you will encounter throughout the year in Provo, which is why people prefer to live in San Francisco. San Francisco is between 49 and 85 degrees. Provo is between 24 and 104 degrees. So if you can get the box plots to line up like this, you know, what I mean by line up is like the markers line up the 60 and the 60, for instance, the 80 and the 80, you can see and compare visually and get an idea of like, well, what this means. Now, in terms of temperature, right, you want your temperature to not go too low like it does in Provo all the way down to 24, and you don't want it to go too high. You don't want days to go up to 104, you know. Temperatures between 85 and 49 are not that bad. And 50% of your days will have temperatures between 59 and 70 degrees in San Francisco, whereas 50% of your days will have temperatures between 50 and 87. Okay, so the box plot is really useful for making these comparisons. Okay, and there's one more thing I want to talk about, so let's go back to OneNote. Okay, so when you make the box plot, it basically has the numbers Q1, the median, and Q3, and then it goes out to this point right here, the upper limit, and right over here, the lower limit. Okay, if you have the minimum number, which may not be the same as the lower limit, Q1, the median, and Q3, and then the maximum, we call that the 5-number summary. And the 5-number summary is basically the box plot, but as numbers, right? Because the box plot has Q3, the median, and Q1. Now the minimum is, so let's say there's a outlier over here, that would be your minimum. And if there's an outlier over here, that would be your maximum. But if there are no outliers, the lower limit and the upper limit will agree with each other. Or sorry, if there are no outliers, the minimum is the lower limit and the maximum is the upper limit. And you can have StatCrunch give you this number. These numbers, sorry. It's pretty straightforward to do it. Okay, so what you're going to do is you're going to go to Stat, Summary Stats, Columns. Let's choose Air Max San Francisco. You can see it gives you these numbers. There's the minimum right here, the maximum, Q1, Q3, and it will also give you the, where did it go? There's the median in here. Median. Okay. So if you go Stat, Summary Stats, Columns, San Francisco, you can see minimum, maximum, Q1, Q3, and the median. Okay, so why is this useful? Well, what's the lowest temperature you're going to see in San Francisco? It only goes down to 49. What's the maximum temperature you're going to see? 97. What's the typical temperature? 64 degrees. We can go Stat, Summary Stats, Columns, do the same thing for Provo, and then you can compare them, just like how you can compare the box plots. Well, what's the minimum temperature in Provo? 24 degrees. What was the maximum? 104. What was the typical? 66. So it's important. This is useful looking at the box plots and looking at the 5-number summaries, because looking at the typical number or the median is not going to tell you everything. If you look, Provo and San Francisco both have a typical days around 64 degrees. But the question is what happens on the edges, especially the min and the max. At a minimum, San Francisco only goes down to 49 degrees, whereas in Provo it goes down to 24. Their highs are about the same, 97 and 104, but if we go back to the box plot, that doesn't tell the whole story, because really, we want to look at this upper limit of the box plot. You really only go up to about 85 degrees in San Francisco, but Provo will go up to 104 degrees for sure. It has no outliers. These above 90 temperatures were outliers in San Francisco. Okay, so thank you. That's the end of the video.